Solve the following problem using the logarithm. So here the given problem is, if a person invests 1000 rupees for 100 years at the rate of compound interest 10% per annum, then find the amount he obtained after 100 years. So here the condition is given compounded annually. So compounded annually means here yearly once we have to calculate the interest on the amount. So this is the given problem. Once again I will read. If a person invests 1000 rupees for 100 years at the rate of compound interest 10% per annum, then find the amount he obtained after 100 years. Okay. So here compound that interest is calculated yearly once. Solution of this problem. To find the compound interest or the amount compounded annually, the formula that to be used here, A is equal to P times 100 plus R by 100 whole to the power of 100. Sorry, N you can write here, not the 100 here, you can write N. This is the formula we have to use to find the amount for the given rate of interest and the given time. Okay. Here P is the principal amount, N is the number of times interest is calculated in the period, and then R is the rate of interest here. So according to this problem, P value is principal is equal to 1000 rupees, rate of interest is here 10%, and the time means the amount is invested for 100 years, so here that is called 100 years. So interest, N value is the interest calculated in 100 years. How many times? Annually once means here one, then annually interest is calculated, so in 100 years 100 times we can calculate, so that's why N value becomes 100 year. N value becomes, substituting these P, R and N values in a formula, so therefore we can get here A equal to 1000 times 100 plus 10 whole by 100 whole to the power of 100. In the next step we can simplify this one. Here 1000 times the 100 plus 10, it becomes 110 by 100 whole to the power of 100. Okay. Now we are simplifying in the parenthesis the value 110 by 100. After simplifying this we can get 0 will be cancelled, so divided by 10 here 11 times and 10 times, so 11 by 10 also you can write 11 by 10, that is equal to 1.1. So in the next step we can write A is equal to 1000 times 1.1 whole to the power of 100. Here now we have to apply the log base 10, common logarithm. So applying here, log base 10 on both sides, so it becomes log A base 10 is equal to 1000 times, sorry, here we can write log base 10 1000 times 1.1 whole to the power of 100. So here you can write like this. So next step we can write log a base 10 is equal to, this one we can write log 1000 base 10 plus log 1.1 whole to the power of 100. Here formula is used, log xy is equal to log x plus log y. This is the formula used to expand 100 times 1.1 whole to the power of 100. So here base 10 you have to write. Now the next step we can write log a base 10 is equal to log 1000 can be written as 10 to the power of 3 base 10 plus log 1.1 whole to the power of 100 base 10. Here one more formula you can use, so that is log a to the power of m base b is equal to m times log a base b, log a base b. So here using this formula, now you can write log a base 10 is equal to 3 log 10 base 10 plus 100 times log 1.1, 100 times log 1.1. So here again one more formula you can write here, log a base a, its value is equal to 1. So therefore you can write log 10 base 10 value is equal to 1. So this one means log 10 base 10 value is becomes 1. Similarly now we have to write the log 1.1 value, how much it is. So actually logarithm of the number, any number that one is given here. So in the scientific notation you can write 1.1 times 10 to the power of 0 only here. So this 0 tells about the characteristic of that logarithm of the number. So what is the power of the 10? That tells the characteristic of that number. So therefore, so log 1.1 value will be 0. Once we decided the characteristic of that number, now we have to see the logarithm, common logarithm table, 11 at 0. 11 at 0. We will see the 11 at 0, what is the value of that. So here 11 is there. What is the value here? At 0, 0, 4, 1, 4, 0, 4, 1, 4, 0, 4, 1, 4. That is the value of log 1.1. Substituting these two values in this. So now log a base 10 is equal to 3 times 1. This one is because log a base a equal to 1, log 10 base 10 equal to 1, plus 100 times log 1.1 value is 0.0414. This one is. So in the next step we can write log a base 10 is equal to 3 plus 100 times 0.04 means after 2 digits we have to keep the point. It becomes 4.14. 4.14. So here log a base 10 equal to, adding these two you can get 7.14. Now if you want to find the a value here, a value, so this log 10 to be taken. This is called as the anti-logarithm. So here a is equal to anti-log 7.14. How to find the anti-logarithm of a given number? So here you see logarithm of the number is, in these two parts are there. One is the whole number part, the other one is the decimal part. This whole number part is called characteristic, and this one is called as mantissa. So while we are finding the anti-logarithm of the number, just we are taking consideration of this mantissa only. So what is the mantissa here? 0.14. So in the anti-logarithm table, 0.14 at 0 we have to see. 0.14 at 0. So what is the value of that? We will see anti-logarithm table, common anti-logarithm table here. So what, where we have to see 0.14, 0.14 at 0. So this is the value 1380. 1380. Now we can write here a is equal to 1380. Okay. Now what is the 7 it represents? Actually 7 is the characteristic of the logarithm of the number. So when we are going to find the anti-logarithm, after 8, 1 more than of that number, we have to take the decimal point in that number. So actually 1 more than of this one is 8. So after 8 decimals, the 8 digits, we have to arrange the point here. So here only 4 digits are there. From left to right we have to count 8 digits, 8 places. 8 places. Now here you see 1, 2, 3, 4, 5, 6, 7, 8. Here we have to keep the point. Now a is equal to, arranging this one, 1, 3, 8, 0, 0, 0, here 0. How many zeros you have to keep here? So 138 after 5 zeros. So here 5 zeros. So now we have to make this one like this. So this is the ones period, and this one is thousands period and lakhs period and crores. So therefore we can write this one, the end of the 100 years that person can get 1 crore 38 lakhs. This is the amount he can get after 100 years.